My name is Dr. P. Jaikanth Yadav. I am working as a assistant professor in Aeronautical Engineering College. And today my course title is Complex Analysis and Special Functions. And my topic title is Milne-Thomson Method. And yes, with the help of Milne-Thomson Method, we can construct analytic functions. Okay, see here there is a small introduction about Milne-Thomson Method. Here, this method determines the analytic function f of z. So, when u or v given, so in a analytic function whose real part is u and imaginary part is v. In this method, they will given to you as either real part or imaginary part. Means real part is u and imaginary part is v. In any of these, one will be given to you. Here, without evaluating other, that means if it real part is given, and we into what we are doing previous classes, we are finding imaginary part. Then we are constructed f of z. But in this Milne-Thomson method, we are not going to evaluate other one. Okay. It's imaginary part or real part. We are not going to consider another one. We directly evaluating f of z. So the procedure is explained here. Here we take z as a complex variable and whose real part is x, imaginary part is y. So what we can have, the z bar becomes its conjugate. Conjugate of z is nothing but z bar. So z conjugate will be like this. Now we can write x as z plus z conjugate by 2 and y can be written as z minus z conjugate by 2y. Right? Now, we know f of z is, it's having real part is u and imaginary part is v. Right? So, we know we are writing x and y in terms of z and z conjugate. So, we are writing z and we are writing x as z and z conjugate, y as z and z conjugate. Similarly, in v function also we are writing the same manner. Here what we are doing, we will take z bar as z. So this we are taking, put z bar is z and we can get as f of z becomes u of z comma 0 plus I of I times v of z comma 0. If you take this transform, you can get this one. Okay. So you can observe that this is the same as replacing x by z and y by 0 in f of z. See here, and this is an identity trick. F of z is equal to f of u of x comma y plus I of e of x comma y is an identity. You feel like that. In this identity, take x replaced by z and y replaced by 0. Okay. Then you can get this one, a new expression, this one. Okay. Now it is clear. F of z is this much. Now we already know if a function fz is fz, which is u plus iv, is analytic, then what is f prime of z? F prime of z we know, which is ux plus ivx. Okay, if I want to write here, u and v are both are involved, but I want to write in terms of only u. Okay, with the help of CR equations. CR equations are CR equations you know, which is ux is equals to vy and uy is equals to vx minus vx. Okay. that is, or I can write this relation as Vx is equals to minus Uy. So f prime of z becomes Ux minus I Uy. Okay, this is f prime of z, but we are interested on f of z. Okay, this is f prime of z. See, this is f prime of z, and we are writing Ux of z comma 0 plus I times V of z comma 0. Okay, so now it will have Ux of z comma 0 minus I times Uy, because Vx is minus Uy. So that's why we can write like this. Now we want only f of z, so that's why it is the integration of Ux of z comma 0 dz minus integration of, we are taking indefinite integral here. So u of z comma 0 dz plus c, because it is a arbitrary constant, arbitrary complex constant. This is constant, complex constant. Then, so this is the procedure to find f of z when real part is given to you. Okay, similarly, the same procedure you can write in terms of v. So that procedure is helpful if the only imaginary part is given. In that case, that procedure will be helpful to you to find f of z directly. Right. So this is the conclusion statement. So we have 4 cases. We'll discuss remaining 2 cases in the next class. So in this class, I'm going to discuss only 2 cases. So here, when real part is given, in this case, we can calculate f of z with the help of this formula. So I just explained how we are deriving this expression. Right. Similarly, with the help of the same procedure as I said just now. So if the imaginary part is given, we are going to use this formula, where f of z can be written as integration of v by partial derivative of v of z comma 0 dz plus I times v sub x z comma 0 dz plus c is the arbitrary complex constant. Arbitrary constant. Okay. Done. So we'll do some problems. You can get confidence. Right. Here, construct analytic function f of z whose real part is given. Okay. So here only a real part is given, and you have to find f of z. Then, so see here, given it is given to us u. So u is having how many variables here? 2 variables, u of x comma y, which is x square minus y square plus x. So what I can write? Then you can easily calculate u sub x. U sub x becomes what? It is 2x. And what is u sub y? U sub y is minus 2y. Okay. Now in this, what I want to do is that replacing x by z and y by 0 in ux and uy. Then what we can get? This becomes ux of z comma 0, because the variable x replaced by z and the variable y replaced by 0. you will have 2 times of z only, correct? And also see, there is a u function, we have x also, for this we get 1, here also you can get 1, right? Next, u sub y, x replaced by z, y replaced by 0. So what you are getting here? Minus of 2 times minus 0, that becomes what? It is 0 only. So we calculated ux and uy replacing x by z, y by 0. These are the terms we have. So we are going to apply by Milne-Thomson. The Milne-Thomson method, what we have, we can write f of z. F of z as integration of the partial derivative of x, partial derivative of u with respect to x at z comma 0. This time we already calculated ux of z comma 0. dz. Next formula. Remember the formula. In this formula we have minus I times integration u sub y of z comma 0 dz plus c. C is arbitrary constant. So what you can get here? Just replace the terms. ux of z comma 0 is nothing but 2z plus 1 dz minus I times integration of uy of z comma 0 is nothing but 0. It is already there. Okay, already we calculated. 0 times dz plus c. Right, now we'll see how I'm going to write. So f of z is, you can see it is integration of, what we can do, 2 we can take here, and z dz, okay, plus integral dz plus I times, sorry, it is minus, no? Okay, this minus I times 0 plus c. So we will have 2 times z squared by 2 plus z. This one is 0. 0 times I is 0 only, plus c. So we are having what? 2 gets cancelled here, and it is z square plus z plus c. What is this? It is fz. Therefore f of z is z square plus z plus c. This is the required analytic function whose real part is x square minus y square plus x. So for this function, real part is this much. Here we are not evaluating v. Directly we are evaluating f of z. This is the beauty of this Milne-Thomson method. Okay. Next we will go for the next problem. Right. Here we need to evaluate, we need to construct f of z, and it is given to you only imaginary part. Clear? Right. So you write, it's a usual practice. Given us v having 2 variables x and y. X is the real part of complex variable and y is the imaginary part of complex variable, which is minus 2 times of sin x exponential y minus exponential minus y. Okay, this is given. Firstly, what we will do, we will simplify this expression. Okay, we will simplify this. So I am writing, or the above statement I am writing, p of x comma y is minus 2 sin x exponential y minus e power minus y by 2 into 2. It is nothing but minus 4 sin x. We know sin hyperbolic x, sin hyperbolic x in terms of x. So sin hyperbolic x formula in terms of exponential function is e power x minus e power minus x by 2. Okay. So similarly, it is the exponential function in terms of y. So now I can write it as sin hyperbolic y. Okay. This is our v of x comma y. Now I'm going to find v sub x, which is also x comma y. V sub x. So what we are doing, I'm doing here the partial derivative of v with respect to x. So the partial derivative will give you minus 4 cosine x sin hyperbolic y. Next, v sub y. Okay, we are doing partial derivative of v with respect to y. So we will have minus 4 sin x, and we'll do, because we are doing with respect to y, so sin hyperbolic becomes cos hyperbolic y. Clear? So here what I will do, replacing x by z and y by 0 in v of x and v by v sub y. We get, so here you can get v sub x at x replaced by z, y replaced by 0. So you will have sin minus 4 cosine z sin hyperbolic y means sin hyperbolic 0. So you will get minus 4 times cos z, and the sin hyperbolic 0 is 0. So you are getting v sub x is 0. Note this. Also, we calculate v sub y replacing x by z and y by 0. We will have minus 4 sin x. Here I will get cosine of hyperbolic 0. So you will have minus 4. See, here we have to write, instead of x, we have to write z. Okay. And z. And cosine hyperbolic 0 is 1. So you will have minus 4 sin z. These two values we have to keep in our mind. We are going to use these two values. Okay. Next, by Milne-Thomson method, we know that f of z can be written in terms of v as integral vy z comma 0 dz, this time plus, because when we take the imaginary part we will have plus symbol, and it is imaginary part integral v sub x z comma 0 dz plus arbitrary constant. This is a complex constant. Now I have already, so we already calculated v sub y. V sub y is minus 4 times of sin z. Here I have minus 4 times of sin z. Okay, right. dz plus I integration of v sub x z comma 0 is already calculated, which is 0 dz plus. Now I am writing, so minus 4 is constant, you can take out from the integration, minus 4 integral sin z dz, and 0, because the integrand is 0 here, that's why the total integration becomes 0 plus here I can have minus 4, then integral of sin z is minus cosine z plus c. So finally what we are having, it is 4 times cosine z plus c. What is this? This is the value of f of z. Okay, this is the required solution. So what is this? This f of z, what is the real part of this f of z? This this imaginary part is, minus 2 times sin x e power y minus e power minus y. So here also you can observe I didn't calculate a real part. I directly calculated f of z from imaginary part. This is happened with the formula Milne-Thomson method. Okay, we'll do one more problem. This. Okay, here what is given to us? Here given that v of x comma y is given, which is x square minus y square plus x upon x square plus y square. Right. So what is required to apply Milne-Thomson method? I have to find the partial derivatives of v with respect to x and y. Okay, I'm going to calculate this. Now v sub x, which is a function of xy, and it is a 2x minus 0 partial derivative. Okay, so here what I can have, you can apply u by v rule. So you can have here, write the plus, take the numerator x square plus y square here, and do the derivative of x, and you will have only one minus, keep x aside and perform derivative for the denominator, which is 2x, and you take denominator whole square. Now you can have 2x plus y square minus x square by x square plus y square whole square. This is v sub x, and I also need to calculate partial derivative of v with respect to y. Now I am doing here partial derivative of y v with respect to y calculation. For the first term it is 0 and for the second term it is minus 2y. Next here x, and you can have minus 1 by x square plus y square whole square. Okay. Next, what we will do for the denominator? We have to perform derivative again for the denominator. Okay, right. Next, we do the simplification. Minus 2 will come here, and we will have minus 2xy upon x square plus y square whole square. This is v sub x, v sub y. Now, what is our next step? We are going to replacing x by z and y by 0 in v sub x and v sub y. So we get v sub x of z comma 0. Now what you will get? V sub x at z comma 0. So first term will become 2z, right? 2z plus, okay, I'll write 2z minus z square minus z square by denominator is z square whole square. So it is z to the power 4. So simplification will give you that 2z minus how much you can get? 1 upon z square. Okay, next we are going to calculate v sub y of z comma 0. Now we will have see here in the vy we replace x by z and y by 0 because first term contains y is multiplying. So okay, first term becomes 0 and the second term is also y is multiplying second term. Okay, so both term will give 0. That's why I can write v sub y at z comma 0 becomes 0. Now I am going to write by Milne-Thomson method. We have, so we are writing f of z directly. We are writing f of z in terms of vx and vy. So it is integration of so once I had to check this. Okay, so vx is minus 2z, right? So the formula already discussed in Milne-Thomson method. It is vy dz. Okay, I'll write in terms of z now. I'll show here vy z comma 0 dz plus I times integration vx z comma 0 dz plus c. So you can see here vy is 0 times dz plus I times integration we have 2z minus 1 upon z squared dz. So it is plus c. So what you can have, first term becomes 0. It is very clear, 0. And there is a imaginary number, and we have 2 integration of z dz. Next minus integral 1 upon z square dz, okay, plus c. Here you can have f of z becomes I will have, okay, so 2 times z square by 2, 2 times z square by 2 minus here integration of 1 by z, that becomes minus 1 upon z plus c. So 2 gets cancelled, and the number I is multiplying these 2 terms. Okay, right. So this implies f of z is equals to, there is I, you will have z square plus 1 upon z plus c. So this is the required, analytic function of z whose imaginary part is x square minus y square by plus x by x square plus y square. Okay, next we have another problem. So in this problem it is given that a real part is given. So what I will take, given u which is x comma y, which is exponential function times here x square minus y square cosine y minus 2xy sine y. Okay, right. So it's usual practice. What you will do, you will calculate the partial derivatives of u with respect to x and y. This is the first step in Milne-Thomson. So here I am calculating use of x partial derivative with respect to x. Here I am taking e power x. Here I have x square minus y square cosine y minus 2xy sine y. Okay. Next, I am doing derivative for the exponential function, that is e for x only, and I am keeping second term same. This time I am going to perform derivative with respect to x for the second term. Here I can have with respect to x is 2x cosine y minus 2y sine y. Okay, so here I need to find this term when x replaced by, okay, this is 1. I will take it as 1. Next to u sub y. Okay. Use of y. Here exponential function take aside. Next one is here we are doing partial derivative with respect to y. So here I have minus 2y cos y minus 2y cos y. Okay, plus x square minus y square. It is minus sin y. Okay, minus sin y. Next we will go for the second term. We have minus 2x, and I have to perform derivative for this. I will have sin y, and the second term will be plus y cos y. Okay, this is equation number 2. Replacing x by z and y by 0 in equation 1 and equation 2. We get ux of z comma 0. Okay, so y is 0 this time. You keep observe this term. Okay, so you will have e power z. Next it is z square. Okay, this time will give you this time will give you only z square because y is 0, and this term will be 0 minus 0. Next this term plus e power z 2z, only 2z, and cosine y and cosine 0 is 1 only. Second term will give you 0. Okay, so what you will have? You will have only z square e power z, and in this term you have 2z e power z, and I am replacing in uy x by 0, y by x by z, y by 0. Here I am observing that in the first term there is y is 0, so this term total becomes 0. In this second term sin y is 0, so sin y is also 0, so this term is also be 0. And here y is 0, so sin y is also 0, so this term will be 0. And the last term here y is 0, so this term is also going to be 0, so you will have 0. Okay, now I know ux in terms of z and vy in terms of z. I am going to utilize these two. So now I am going to do by Milne-Thomson. So method we have, I am going to write f of z in terms of u, that is integral of ux z comma 0 dz minus I times integral of u sub y at z comma 0 dz plus this is the constant, arbitrary complex constant integral. So I already calculated. It is z square exponential z. Okay, z square exponential z plus 2z exponential z into dz minus I times integration of 0 dz plus c. So I can have only integration of z square e power z plus 2z exponential z dz plus c only. So this I can write it as integration of, see, the whole term can be written as in this form: derivative of z square e power z plus c. This whole term I am writing as derivative of z square e power z, because derivative of z square e power z is z square e power z into dz plus 2z e power z into dz can be written into this form. Now you can write it as it is z square e power z plus c. Okay, this is nothing but what? F of z. So here what we calculated? We calculated f of z. What is given to you? Real part is given, and we calculated this. So I hope these 4 examples are enough to understand Milne-Thomson method when real part or imaginary part is given. So this is the summary I am using. I am calculating f of z with the help of real part. This is the formula, and I am calculating f of z with the help of imaginary part. This is the formula. Okay, so these 4 examples are enough to understand this topic. Okay, these are the reference books for this course. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.